Okay, we'll try this. එතකොට මෙයාගේ image එක the first person's image first කෙනාගේ image එක මෙයාට object. ඒ කියන්නේ කපලා ආයෙ yellow color එක දාන්න. ඔයගොල්ලෝ you can use different colors. Is this hard? Maybe any questions I can ask for the exam. Right? I can change the numbers and ask the same thing. Yes. මේක තේරෙන්නේ නැති කෙනෙක් ඉන්නවා නම් මම කියන්නේ I can't spend more time for questions. That is why I have given you the presentation beforehand. I hope everybody got it. First කෙනාගේ V එක ආවේ 0.5 meters in positive. So ඒකද අපි ඒක දානවා. But අපිට කියලා තියෙනවා 3D second lens එක තියෙන්නේ 1 meter දුරින් කියලා. Given as data. එතකොට මෙයාගේ නිකන් එකපාරට එන්න දෙන්නේ නැහැ මේ image එකෙන් යන something එකකින් ඉන්න ඕන හින්දා මෙතන minus ඉතුරු ටික set කරගන්න for the sign function. But the total distance is 1 meter. මෙයාගේ 0.5 එක ඊට පස්සේ කවුද වෙන්නේ u මෙයාගේ p අපෙන් අහන්නේ b එක කොච්චර. So use for the second lens u වෙන්නේ -1/0.5 that is -2d 3d plus divergence equation එකට දාමම v එන්නේ 1 diopter. So that means it should be 1 diopter right to the second lens. And එහෙම පොඩ්ඩක් පෙන්නලා හදලා ඇඳලා otherwise you will not get the idea. Can you sign the sign and please? Everybody sign? Please, come on. So suddenly means we have another person for the WhatsApp group. Right? That much. Last time, only few like you didn't do. Did you do the exercise I gave? Keep it. After video game, right. And the explanation did you get the idea of this plant? Okay, can manage it? Okay, the full one. Are the label I finished it? But last time it was like 15. Okay. Shall I move on to the next one, please? Then citing the angle. Okay. So did you get the answer properly as 1 meter distance second second lens second and image right. Next. Now, not only lenses, I told you optical system. So optical system you can take a prism off. And 2 prisms can look. But what will happen? Prism transfers So again, you can do it in two different methods. Right? So it is possible to so I'm not going to ask such thing, but I will ask one lens. I presume that so I don't want to confuse you all. So I'll try to be more simple. When what will happen? Prisms cause light rays to change the direction. Use prisms if I say, okay, what you have to do? You have to introduce a prism in between. Not only the lens, change the direction. You need to introduce a prism in between because by refraction it goes somewhere else. Right. I told you light is a wave. එතකොට ඔගොල්ලෝ දැකලා තියෙනවාද wave fronts? What is a wave front? නිසල ජලතල ප්‍රත්‍යයට ගලකට ගහලා දිනන නේද? So what you will get? Some wave. So Vergences describe the curvature of a wave. Wave phenomena So geometric optics considers the propagation of spherical waves. So how to find the convergence or divergence using waves? So the curvature of wavefront is then given as 1 over r. Near the source, the curvature is very large. Long distance now, wavefront is nearly straight. So the divergence is defined as V equals n divided by r. For here, the n is the refractive index. And here r is the distance. The main is positive minus negative convergence, divergence. So here we are talking about phase. Light rays and see minutes. Is another new word. Yes. So we are talking about what is effectivity. Right? So I have given two lenses are said to have the same effective power if they form a real or virtual image of an object at the same point. So if you can see it, we are 100 centimeters lens same distance can be done by a +2 lens with a less width. But +4 25 making told you the distance, the reciprocal of the distance is equal to focal length. So this is called effectivity. So I can ask for the exam, can you please explain effectivity in your own terms and draw a ray diagram to prove? That is it. Means like that's it. You get full marks. This is a like part A B question from you. Hey, what is it? Be sure. I picture lamai berry na mokada window ni mata. Google it. Okay. Right. Can you please Alright. So this is what I wanted to mention. New formula. Yes. I'm talking about the aperture. What is an aperture? What is that? The amount that you change in the entrance of that way, which is inbuilt in our human eye. So we also have optical instruments that have aperture sizes in our. What are the aperture sizes? We talk in f-stops. What are the f-stops? Photographical method. Asal photographical method. Cannot. What do you do? Optical. Okay. Or here. 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 Right. Vijay Potak now, yes, what about you? You are after the students of exam, but yes. What do you do good times to free time? Yes, your name is TME. I'm not a name, but TME, yes. And you go there, you are getting yes. TME, what do you do? Huh? No, what do you do in your free time? It's like another group are dancing and other music. See, last time I asked, what do you do? What do you do? Huh? Draw. Yes. Read. Music. Many things can. Before to be like me, that you have to do many things, I can remember. Yes. So, like still photography or whatever the stuff that you're doing. And you know, art gallery. Yeah, the Ramai Kaptan, I'm going to add it that way. It's production of Balanda, Kala, Moda, Far, it's also of Yanda, and I told you I normally go out with the students after the lecture, but I just go for a walk. Actually, I don't know how we are, but I notice many things. I don't have like people to tell me you're implementing people may think I'm crazy, but no, there are certain things just the mother put to the that's why I asked whether you are doing photography. You definitely specifically know ඒ ගහ මොකක්ද? ඔයාලා ටස්ටි කරලා තරන්න දවසක යනකොට tree walk. කවුද? මේ මම දැන් විහාර වහදී එක පැත්තේ කරලා මෙන්න මේක ගහ ගිහිලා ගහ අත ගන්න. These things are done in foreign country. අපේ තමයි ඕක ගහ බදාගන්න. අත ගන්න. කොළේ අත ගන්න. මාල් වල වීඩියෝ බලන්න. You learn the tree and the importance, the scientific name. And over bird watching, you know, I am well, I guess have you been there? How do you do? We are good at the bird watching boat trips, and then the boat taking I really admire this. But back the guy in the park at he did it. He won't see Mandani. Photo behind the thing. No. I'm going to collect that and can reach. We can reach. I'll put a Ida for Wing. I can somehow what is Nikumba? I'm getting you must have to guy. In more than yeah, but that's not like you know these things. I think much content about how do you evolve. And I'm talking and the stuff. You ask it. Photos and binocular can and you're part of nature. Normally, as an education consultant, I normally arrange such. Get a guide. I'm not a pro person in ecology. My thing is physics. So the guide the end of it. Modular can come there. Timing school right? Beach yoga sessions. Rani have better. Yeah. I am good. You will Rani. No, these things because I really like. Our killers and will not no, you are not into movies. Lanka cinema Parmante, I don't know. You know, Rani was based on a true story. Have you heard about this? Richard Listens. He was a journalist, personal news anchor in Sri Lanka. In the 1980s. I told you I was born in 80, so 88, 89, Kalabalakali. So I was like 5 years old. And I remember this chaotic situation, what happened. He was murdered by pregnancy. And this running is running to cellular that person's mouth. How she tried to win the justice for her dead son is depicted from this very true story. What has happened in story. And Arawe Dutugamu, Kata Kati, Devaraja, we are functioning on Rada, like this is a true story, but I really like this. Epic. But something happened to Reenact. You are enacting something. And she was a specialist doctor. I don't know whether you have heard the actress Swarna Mallavarati. I think it's her epitome of that. Yeah, we do not care. We bala di masam. We amala the bala. Eki, we not hanta ni. This is a physics lecture. So, right, just to break the monotony, I wanted to mention why the aperture is there. They have a certain number system, such as 1.4 to 2.8, likewise. So, f stops will link here. The lower the f stops gives more exposure. Like the fewer the x stop, maybe 1/16 can shoot here. So what will happen? It will not allow any light to go. It's a less exposure to the light. Next. Radius of curvature. So radius of curvature, small radius high radius more than. So it can be seen. Large radius now, we normally say it as a low curvature. Small radius now. I told you that. Right. Methane did you get it? Right. Any activity do you like to do today? Do you have a jar of paper? Do you have enough paper with you? One for each. I will give you 5 minutes. Throw something in your mind. Like that. Something in your mind. Just throw. That's the activity. Yeah? Quick. Ayo. Be quick. Draw something in your mind. Quick. Just draw it. And those who finish, we just show that. Whatever thing that you have in your mind. Right now, what do you have in your mind? I'm not asking about it. Quick. Something. Oh, I'm studying the last to your school time. I'm drawing. Anything that you have. Name okay the song, yes. It's okay. Duck. I duck. Can I tell you? Any product you have that? What do you think? Yeah, rules expical Valentine is me. You are. Yes. Yes, that's all. If I'm not thinking about that, what about Yes. Okay. Big helicopter. එතකොට මේ hospital wow, great. I'm hard to hear. I'm always going to like it. Okay, this part. Okay. This one. Like you carving up, yes. I have it's a lazy. I have six. Yes. Right. So gospel and the choir relate nature lovers. We have ten animals, yeah, they have that nature part, but they miss it. That's what they do. That could not have the Babalo, so it can let me answer. I don't know. Whatever you are, I hear reliable medical security, right? And buildings, unnatural buildings and the man-made things. Yeah. So now the gateway, a car, and that venture capital building. Right? So that shows you are oriented more towards the future. Then we don't have that venture capital building right now, so it's your future. Okay, yeah, right. Wanted to do some modifications. In a lasana parisara, that's why you wanted to draw. I didn't know anything. So everything, yes. That's what being a consultant of education is about. Second exercise. Right? When I can die, I want to everybody knows and seen a bird. Alright, draw a crow. Come take in the one. Then I'm going to make normally this exercise goes and draw a duck. Yes, yes. So Kako that was everybody has seen first. Have you done art in your life? Okay. Yeah, because you are taking the scale. That's oh, birds landed the crow is nice. So side cut yes. Side. Side. Right. Fine. Side. Bargain. Oh, nice. Next one. Alright. Go. Yeah, we put the it's bird. Next one. Park around yeah. I am yes. That's your park. Oh, nice. Park you are. So there are different countries, so I'm happy that you were able to draw. Good, and that shows. I will have a question. Is that person she? I own front view, back view, side view. On I got the side view. Yeah. So you remember the bird in the side view. I didn't talk about it. Yeah. But why did you draw? Because you were more comfortable with this. Oh, Yes. You had an icon financial card. Can you show it? Yeah, it's really nice. I really appreciate it. You drew something different. I am my contact for that. I know, I thought. So it's there. Like, so I told you to draw the same thing. Today, same thing is differences you put that in. Everybody drawing the same product out of the box. Which can't be a killing bother, yes. Dimbala like out, one day, Dimbala like the cathedral forever, right? Dimbala, how we can see a cock upside down, that dominated. Yeah. Flying, it means that we have seen in the flying mode. Right? Next, the next happens, we can about that. I can't go either than top there. If I've seen the nest, some of the arctic right? So that means, and if you have seen it alive, you definitely will have drawn. The live developing is until, not in the natural habitat. So, associated with crop back and then. Yeah, the line so think about, I mean, shift your battle. Imagination like product. You don't stick to a certain frame. You are in that frame. Frame can. So go out of the frame, go out of the box. Life is February 11th was the International Women's and Girls Day of Health. And I participated in the UNESCO main conference in Paris. No, if you're going to make a I also called it. Empower women, the world women in Paris, all the future. So be alert about it and we'll go back to this. So what is a large radius and a small radius means? Normally, we think about the whole circle. Normally, do you do it? So what you are doing? The center of curvature is the same distance we take. Right? It will take 2 meters, whatever, 1 meter and center of curvature look that means but the same distance because of the curvature. And the can you see steeper curvatures? Surface. Right? So that's why you said you check the lens size, mirror, and surface and the answer. Radius of curvature is high and low. So what does it mean? If you take a full circle, what sort of distance that the particular person has to travel while you are talking about the magnitude of the surface radius of the. Right? Next. What is a sag? The height or depth of a convex or concave mirror. එහෙනම් අපි ගන්නකොට ඒ lens diameter එකත් එක්ක ඒක දැන් මෙතන lens diameter අර තියෙනනේ full මේ ඒකත් එක්ක මෙයාගේ මේ curve surface එකත් එක්ක තියෙන උස for concave convex. එන්න මේ උසට තමයි අපි කියන්නේ sag. So මේ different lenses වල sag එකේ value බලන්න හිතනවා මේ අතට. Check whether you understand this. So this is shown in this. What is it? It's about a geometry about the surface. How are you going to talk? If it is a convex lens, you take from the depth. If it is a concave one, you take from the outside. Then second outside. Because you have to think about that an imaginary circle. Let me click on the. Okay. Now, next one. If it is a short radius and a large radius, have the same diameters up to draw. if you think about it, it's a large happening at the advertisement because of the radius. So I have shown that. Because there's an equation, this sagitta is equal to half diameter square divided by 1000 radius. Okay, equation is how to calculate the lens diameter diameter half square. Vedanta 1000. This one. I'm not asking these mathematical stuff. This is where information and extra knowledge. හරිද මේ සැජිට් ෆෝමියුලා එක ආවේ කොහොමද නැත්නම් කෙලින්ම ෆෝමියුලා දුන්නා මොගල ඔතේම පාඩම් කරනවා. So how it came like this. No need to worry about formula එක මතක තියාගන්න ඇති, but how you derived it using Pythagoras. Can you see? This r square is equal to Sagittarius is s, r is your radius. So if we take this part, it should be r minus s. Pythagoras make a half made a full meter length. Sagittarius, this part is half a d. So from r squared is equal to mea plus mea squared. Pythagoras. අපි එකෙන් equate කරනවා s අපිට ඕනේ Sagittarius එකේ value එක derive කරන්නනේ. So we derive this s. So square roots, everything is in there. You have that. Try to get on your exam with 100, but how to get the expression using half and squared and right? So that's it. Yes. Some are approximate values that you are making, but you don't have to worry about this. But in the basic theoretical, if it is in millimeters, values so it's like that. So because they do the approximate. Right. Next, the effect of refractive index should not be overlooked. A lens material with a higher refractive index will blend the light more for the same amount of curvature, and therefore a lens material with a higher refractive index requires a less curvature to produce the same surface power. In turn, less curvature, that is longer radius or curvature, results in a smaller set. What is the connection between sagitta, long radius of curvature, and the refractive index? Did you get what I said? Whether you understood? For example, previous lens surface 6 diopters. Round hard with a resin, index 1.5. With a diameter of 60 millimeters. And මේ ඔක්කොම values දුන්නහම අපි කොහොමද sagitta එක ගණන් කරලා බලමු. ඒක තමයි දාලා. ඒක ඔයගොල්ලෝ දැක්කම value එක එනවා. Actual sagitta is 5.6. Approximate එක ආසන්න වශයෙන් අපි බැලුවොත් 5% margin එකේ තියෙනවා. මේක හේතුව මම කියන්නවා. Normally, if you calculate some value and you get a value with more capital, you get an x value. You know the true value. True value of acceleration due to gravity here. Gurutva ke tarane aage here 9.8 ms minus so you do some sort of an experiment and you got the calculated value as laboratory conditions. You got a value of 9.1 ms minus. Is this correct or not? Correct 9.1, 9.8 is the real answer. We got it calculated by 9.1. So what we do is we check the percentage of error. How? We divide by this 9.1 divided by 9.8. එතන මොකක් හරි පොඩි value එකක් තියෙනවා නේද? So if this value is less than 5% නම් acceptable. If it is more than 5 to 10%, that means you have done a wrong calculation or what to do. सामान्य අපි බලනවා ඒ range එකේ plus or minus 5% range එකේ තියෙනවා. You have done the experiment in a proper way and you have got the calculations correctly, but numerically කොටක් නෙමෙයි. For example, if you got like 8.1 or you cannot, that means your error percentage is higher. So you have to repeat the experiment. You have to repeat and get something here. Remember that? So in physics, what we do is we check the actual value of the longing value. That's how you do an experiment. So method the accurate range, the actual value is 5% range. Why? When the 5% range is මෙයාගේ 6B එකට ළඟින් යන එකකට සෙට් වෙන තමයි මේ ගාන හදලා approximate කරලා 5.4 millimeters අරගෙන තිබුණේ. Did you get it? මෙයාගේ equation එකට දාලා අපි fine tune කරගෙන මේ values මෙහෙම set කරොත් හරිද අපේ sagitta value. I told it's in millimeters line එකේ කියලා කිව්වනේ. So ඒක චුට්ටක් බලන්න මේගොල්ලෝ මේකට ආදේශයකට so surface power එක 6D එක්ලියන් එක sorry half diameter අපේ මේ කලින් සමීකරණයට ඒගොල්ලෝ දාලා this one equation එකට they have put the real values and found the sagitta value for as a particular example. And overall, the values දාලා බලන්න we can sagitta value එක 5.4 millimeters. Right? So that's a calculation one. So you can do it at home. මම homework එක කරන් එන්නේ කිව්වේ මොකද? Scientists එකෙන් ලියනවද? How many of you did it? Can I see? Can I see? Who are the like important in the first presentation there was scientist name, right? Along with the yes, one different go. Yes. Christine Hygiene, Thomas Young, Harry. Right? Yes, Maxwell Controleva, Niels Bohr, Albert. Wow. But now this right. Good. Oh, there was it. So you got certain idea. You next week, Madam. I'm not asking you to go about that. Because these people will talk about their findings in this. So next week, you will get more. Next week, right? I don't care. I'm at 42 points. Refractive index, sorry, critical angle. One thing is that. What is the point? Yes. Very good. Possible, like one stubborn. Just two. Besides, you found something. So, what did you see these? Actually, in common. Let me know. That's it. Then, did you notice something in common? What did you notice? Maybe cutting among quantitative. What is that stroke? Loss interest. Yes. Picture the one homework. If you try out the other questions, I think so. Homework questions के बने बता क्या बता आपसे वो बड़ा मान लिया very good और our teacher लोग तो एक दिन आवा कि it's very nice. Yes, I really appreciate her work. Mr. Balla. One work के वाला वाला I like him. Yes. Everybody well commander. Maybe I can give it. You need to complete it. I told you to have a separate book once because it. अयो मां पूरा इधर लगे लगे ना इधर मां बोला ये हो रखते ना लोग बोले कितने I stay up waited for 10 minutes time and this only time I am almost in until what did you see these scientists in common mang engla handle haven't you noticed वो मेरे को lifestyle में बोलता लगे so my next question is this home. I mean, put that up. Mommy, ये ना काटिएगी. Okay, I'm searching the name properly. Sorry, can't get it. Da Vinci. That means they are another Da Vinci. I don't know if I'm Da Vinci, Einstein. So it alien make काटिएगी मतलब similarity को एला दे. मुकाक कर दिया ना. अगर मैंने मुकाक दिखने को एला दे. right? Da Vinci. Einstein, Tesla के आने electromagnetic spectrum Tesla, not the car, and Rumi के आने दार्शनिक एक किया है हमें, that's a philosopher's name. Rumi and Plato. You know the Plato yet? These mangai have two colors in the These two are philosophers. These two are scientists. Right? The connection. Plato, Rumi is not for optics, this is for your curiosity. Right? Plato and Rumi are philosophers. Da Vinci, Einstein, Tesla are scientists, those who have done experiments and did some inventions, had some innovative mind. What's the time? The question. It's homework. So you need to do certain research. You have in your diploma certain so I'm helping you all how to do research. Right? First do this is called you think about the person, so you are taking the biography of a certain scientist. Select you found the person's name and what did you do. Here I'm asking to look what they have done and find the connection. So two things. If I exercise security of what did they find, here try to find the connection between these bunch of. Okay, so that's it. Next. And the overall lens power is simply the sum of front and back curvature. Then if you have something like this, surface lens power Q 6 and minus 4 I versions front and back. Total is this much. It is coming as a parallel. And why? Because we normally check the base curve. Using the lens clock and all. How many of you have used lens clock? Lens clock. You have not used it. So normally we check the options like base curve, back curve, and picture. So you do and check all the versions. Here we are. What is a lens clock? Lens clock is a mechanical dial indicator that used to measure the dioptric power of a lens. The lens we haven't done it. You have seen it somebody do it? YouTube how to measure. Practical I don't know, but I normally This is not in your syllabus, but I put it because it was included in last year diploma. අලුතින් ගානේව මම අරගෙන මේක නෑ කියලා ඔක්කොම මේ කයල් නැතුව අනෙක් එක බලලා නෑ නේද? මම වැඩිපුර දෙයක් තියෙනවා වැඩිපුර දේ දාලා ස්ලයිඩ් ටික වැඩි කළා. I have to give you more information and knowledge without taking out the thing. Okay. That's why I'm like omitting some of the slides. So if you are looking at versions, so you have a complete guide. You don't have to look at an extra whatever the supplementary books on. You get the diploma level knowledge from this. I think I know you don't have to look at the other books also. How about the other lecture? You had chemistry last time. How was it? Yes, your phone is charged. How was that chemistry? Chemistry again to run another show. Yes. I haven't seen chemistry because I really didn't like chemistry when I was well, biochemistry is like, oh, sure. How was it? Huh? You remember? You liked it? Yes or no? You like physics? No. Yes. Physics of the power. Physics and chemistry. Chemistry was like physics of that. They say, I'm going to do that. Rather than not, I'm going to why we need to talk, right? My students are like moving over towards chemistry. Something is missing in me, I don't know. What are they doing that? Starters? Elements. What are the kids? Elements you periodic table every day. It's that. Anyway. So I wouldn't remember those structures and everything. What happened to the chemistry then? That is like, so if you find it interesting, how did you get it? The chemistry now very so if you really love the subjects, yes, do it. Books in your real life, like physics. And then other one I'm going to give presentation again. With that. So you remember now, that's good. You remembered what he taught. Try to get that presentations that are how make a clear like workload. That's what I'm saying. So did you get my presentation last week? You what? I'm good. Did you get my presentation? Well. So it's easy for you all. And lens clock again this one. So how do you start to measure? Lens clock there are three prongs. Three prongs. Make a heater, right? So you put it there. And what you do is there's a surface. You can measure the curvature and other lenses if you want. When the three prongs are placed in a flat surface, curvature of that is showing the value. Okay. What will happen if you keep it in a surface like this? Then we have value make a black and red dials. I have a balance use color. Black dial pin curvature of the surface. Black a lens clock measuring plus save of black, minus save of red. So make a gila is the mea monogated candles. Convex. So I have a plus minus of according to the surface, you should be able to tell the radius of painted diameters, not in meters. Diameters. How about another one? When a lens clock is held against a concave surface, two. Make it minus. පැත්ත වෙනස් නේද? clock එකේ මේක ගිහිලා තියෙන dial එක ගිහිලා තියෙන එක on the back. එතකොට front එකේ front අපි lens systems තියෙනවනේ. lens system එකේ ඉස්සරහා front මේක +5 පිටිපස්ස එක -2. එතකොට අපිට divergence equation එක දාලා යන්නේ කෙනාගේ මේක හොයන්න පුළුවන් නේද? Right? So that is a simple indication. Just measure it. Make bundle, can you understand? So tell me, not only for lenses, you can check for your glasses. That's the product. If our surface again, idea have done from Miagar in Mata level Karama, character pasta. Over you get the value right. Because in the near future, we are going to do lens maker equation here. But I'm doing it again for the completion. I have done it. So, any questions up to now? So, what is vergence? What is accommodation? In vergence, there is convergence and divergence, and we have a vergence equation. P, UP plus P. U is the incoming, P is the optical system data after B is the emerging light. Okay, value. But if they ask in a question, if they ask the distance, you have to write it in meters. If they ask the power, you have to write it in diameters. So afterwards, we talked about the radius of curvature. Taking it as we came to Sagitta. After that, we found the Sagitta equation is there. Take an approximate formula. Once it is with a different material, we have another equation. First equation is the general equation. Second equation is with the refractive index equation. Equations get up. Then we came to lens clock as an equipment or a tool which measures the surface. By looking at the dial color, so on, we can have an idea about the surface. We can use it to the lens surfaces as well as to the vector. Right? Next. One question now. So, what is the problem? Make a product. So, this is a thinking question. Read the question and maybe there are possibilities. There can be possibilities, but what's your optometric knowledge opinion? I go. And customer gets her eye exam and it is determined that her prescription has not changed at all since she got the last pair of glasses. Even though her current glasses are still in good shape, she decides to get a new glass. Right. You make her new glasses with the exact same prescription as her old glasses. Check the old prescription and doing the old glasses. The customer returns the store 1 week later saying that she can't see as well as the new glasses with the old. Regular prescription එක වෙනස් කරේ නැහැ. පරණ prescription එක අවුරුදු ගානක් ගියපෙකම ඔයගොල්ලෝ check කරන්නේ ඔයගොල්ලෝ තායි අලුත් එකක් හදලා තියෙනවා. දැන් තමයි ඔයගොල්ලෝ check කරලා බලන්න. එහෙම වුණොත් what can be the possibility? අද ඉගෙන ගත්ත දේවල් වලින් මේක අමරලා මට උත්තරේ කියන්න. So there can be what could be the problem? So I have given 2 possibilities. මට හිතෙන possibilities. ඔයගොල්ලන්ට ඊට වඩා දෙයක් හිතනවා නම් let me know. Set up on distance. Can be different due to certain age also. So Mama I am looking from the physical aspect, right? Mama according to what I know in vergence. So what's the first possibility? It could be the base curve. Right? Using a lens clock or whatever, measure the base curve of the old and the new pair of glasses. I don't know the inside. So anatomy, I don't know. What you do is the problem is if the glass, the problem with the glass, new glass, we should check the glass. The target question, I don't know. So it could be using the base curve is different. Between the 2 pairs, it could be very difficult for the customer to adapt the new glass. Particular by the right? Yeah. Possibility two, if the base curves are same between the two pairs, another possibility could be the intersection, what is it? Sorry, incorrected capillary pupillary distance. That is, yes, or see, ocular center of the eye. So this is your optometric idea. This is my district idea. They come up in the good. So any other that you know, Mama, you must get the good possibilities.
Frame size question, but that would be also.
Frame size.
What do you do the frames, maybe it is not exactly the inflation period and because
Okay.
the different.
I think not. I didn't do it. But it's a long time. I get to a line and go Mahatma. So what people are depending on that. Can be. So what have you done? I don't do it. I don't know about your customers. I'm idea. It's not possible. Yes. May make yes. Open and for out if you have a shop like that. What are you going to do?
Then maybe the refractive index of the lens when it comes to the normal refractive index, we may report the high refractive index can be the vision ability.
For the material.
Material and refractive.
Also, the kind of customer and love out this solution. Yes. Done. What do you do? You are working part time in somewhere else. You know the training. You know the. I know this is not a good ethic. You cannot but you can see that. Our problem identification. So, open me open and many customers level customers they come with the problem. So, problem solution is that they come to them. Yeah, where senior opticians are. No, you are learning. You haven't get it. You have to learn from your customer. You will get various types in. Right? After so many years, someone out the maybe 2 years or anything. 1 year. Once in another, once in every 2 years, I'm not about like 6 months. And 5 are and along with that, yeah, because of my case, I get early prescribed. I need a calling matter. Done to put as space. It may be the reason we were most engaged with this Chinese stuff in the laboratories. Remember, it was like in millimeter level, we used to do experiments. The athletes are ready. And also, this computer screen is also there. And before 30 minutes, by 38, I started to wear glasses. After me, I was like, you, I still have the problems in we were moving to the bear. So it's there. So as vision students, please even other than what we can give once girls we have the beauty care routine there. Then it's banana, yeah. I'm not gonna okay, yeah. I'm giving a kiss. You don't do that. Boys, snap. Oh, once in a while, you don't go to a salon? No. It's a ton of moisturizer, facials, medicare, not current. Also, Baba. Whatever you have a routine, likewise, have it to your eye flow. I mean, eyes, I have it just about noticing. I did everything, but I didn't care about my eyes. Let's see. Next. So the optical power of the surface are calling of a maker. So you normally have it with the crown glass. So radius of curvature can be found out using this equation. And you said like that, you can put the corrective lenses. I don't know whether you are doing these things manually. You don't have to worry about this. So for example, in a question, so this is your application question. Put back here and take your time. A biconcave lens made of flint glass with an index 1.7 is measured with a lens clock calibrated from crown glass, index 1.523. On the refractive indexes, they guide. For this particular lens, the lens clock gave the surface power -3 and -7 diopters. Because the clock is calibrated for different refractive index, crown and flint, what to do? So the optical power of the lens is not the sum of the surface. Because of two materials. So the optical, because of this reason, the optical power for the lens is instead using like this. So R1, R2, අපි වෙනම බලමු. එතකොට එයාගෙන් එන values වලින් අපි again බලන්න ඕනේ flint එකට කොහොමද. ඒක කරලා ගන්න deductions තමයි actual power. Right? So, yes. And there's another thing called estimating the thickness of extra stuff that I have given. And I wanted to talk about this. Paraxial approximation in geometrical law. So, we have sin theta value is equal to tan theta value. A-levels, have you learned that? Now, in an optical system, whatever the subtended angle of theta came from, if this angle is less than 5, whatever measured angle is less than 5, now, normal approximation tan theta value is nearly equal to its sin theta value. When we approximation approximation in geometrical optics. So this is I have given. Normally in general geometrical optics, when you are drawing rays, simplifies the optical calculations by assuming small angular deviations are accurate for under 10. Under 10 5 normally appear range physics under 5. 10 කියලා අපි සාමාන්‍ය පහට අඩුයි නා මොකද මේ values යන්නේ sin theta ඔබ බලන්නකො sin 60 ඒ වගේ ලොකු වෙනකොට වෙනස් වෙනවා sin 60 tan 60 values වෙනස් but ඔය කියන විදියට tan 1 sin 1 tan 2 sin 2 වගේ values බලන්න nearly so angle එක අපි ඒ subtended angle එක අනුව we normally check that approximation. When does the paraxial approximation do not apply? When normally it's a choice, but you can apply in different questions. Why? When the angle gets larger, can you apply it? When I told you if it is less than 6.5, and what is the other situation? Paraxial approximation is often used in the analysis of wave guides in optical fibers. By divergence එක දුන්නොත් මොකක් හරි in a given length එකකට හැබැයි සමහරක් වෙලාවට එලා ඉන්න rays වල පොඩි problems එන්න පුළුවන් හරියට වෙන්නේ නැහැ. වෙන්න වෙයි. When you are working with අපිට calibrate කරලා හොඳට focus කරලා කරනකොට ඔය කියන sin and cos tan ටික equal කරන්න බෑ. It has to be focused in a proper angle to a minute detail. That in optical instrument. So, avastha දෙකයි. එකක් angle එක larger. අනිත් එක more focusing on වෙන අවස්ථාවල you can't do this paraxial approximation. Y here, I have shown. Well, maybe 2-point sources here. Right? 2-point sources here, we can diverge, approximations. If we normally left to right, we look at the ray diagram from this. Diverge, diverge, and they give me the paint. Two origins approximate even this can be very minute nanometer, but 2 different points. Sometimes may they not coincide when one sin theta tan theta equal, but not so once you are thinking about the accurate focusing situation. And anything else that you need to ask right now? Today's lesson? Because that's the end of the lesson. So, okay. So that's done. And last time questions like 100. I'm ready. Yes, question. You know how to stop the recording? I have no idea. It's fine. Stop sharing the or else. This? Shall I switch? Okay, with the transcript they are getting me. That. Yeah, what are the questions you have? Yeah, ඔක්කොම ටික object is being solved. Make an object. Sorry, S is the speed. Or if the object light source is set to 1 meter from the vertical stick. We can I think the light source is set to 1 meter. Vertical stick of length 0.1. So that 1 meter length is 0.5. And placed 4 meter beyond the stick on your opposite side. 4 meter adding that's right. We have 1 meter source of adding then beyond the six. Yes. Estimate the length of the shadow. Shadow can happen. Length of the shadow. Shadow can. Well, any questions? What? This one? You need to leave. Okay. It's working. Yeah, I don't.